So I'm going to be throwing out a lot of questions out there this afternoon, so please bear with me. But who here has ever heard about jollof rice? Oh, quite a number. Okay, who has tasted it before? Oh, interesting. Okay, for those that don't know, jollof rice is a dish that originated from West Africa, and it's made from a mix of onions, peppers, rice, of course, oil, any spice that you like, you can just throw it in and then you get a delicious plate of jollof rice. But even though jollof rice originated from Africa, it's very popular worldwide, especially among people of African descent. Well, here's one question for you. Which African country makes the best jollof rice?
Where are you from?
Nigeria.
All right, that's a very controversial topic, but you can get from my accents, right? Yeah, that's the answer there. Anyway, let's leave the controversial topic. One thing that we can all agree on is that there is increasing impact of geohazards, natural hazards, on critical infrastructure across the globe. So how are we dealing with this changing impacts? There's increasing rainfall intensity, there's increasing temperatures. How are we handling those as geoprofessionals and owners of critical infrastructure? So going to, zooming into the US where we are right now, there are maps that have been created by FEMA that shows the estimated annual losses from potential occurrence of landslides, earthquakes, wildfire-induced hazards, and also flooding. So again, another question to you: how are we addressing all these changes and the impacts on public safety, on property, and then the built environment? I guess you're wondering, this has nothing to do with the title yet, AI machine learning recipe in geotechnical engineering, but you will find out. So, taking you back to jollof rice, you can tell it's one of my favorite foods. Traditionally, jollof rice is prepared on firewood. You can see the pot there with the fire. You get smoky, flavorful jollof rice from that. More common now is stovetop cooking. So, with the right recipe, with the right ingredients, you will get delicious jollof rice. But recently, I came across a YouTube video about oven-baked jollof rice. I'm like, okay. So the idea is, if you have an oven-safe dish, you put in all your ingredients, with the right quantities. You mix them all together, put them in the oven, set the temperature, set your timer, walk away, and then when you hear the beep, you come back and you have jollof rice ready to go. So, does it taste as good as the firewood jollof rice? That's a topic for another day. All right. So just like there are different methods of preparing jollof rice, there are also different methods for geotechnical and geohazard assessments. So from empirical correlations to analytical methods, numerical modeling, and also AI machine learning. So machine learning is a subset of artificial intelligence. So more questions. How are we responding to AI and machine learning in geotechnical engineering, and how is it influencing our day-to-day jobs? So I will give a comparison between baking jollof rice and the use of machine learning in geotechnical assessments, again, for critical infrastructure. So you need a recipe. So you start out with your recipe, and the first thing you need to gather is your ingredients. So ingredients equivalent to your data, right? So in that funnel there, leading into my model, I have my terrain data set, so topographic information, geologic information, my geotechnical parameters, airborne data, field-based data, everything into that funnel there. Then you bring in your triggers. So is it wildfire? Is it rainfall? Is it earthquake? Again, within the same funnel. And don't forget the critical infrastructure. So your roads, your communities, everything, your pipelines. in there as well. And what do you do with this? Well, we have to prepare ingredients. So you process the data, make sure there's no noise in the data sets, make sure you don't have outliers that are not relevant for your modeling. And then the cooking process, so the baking. Now you train your model. And the most important part of your model, building the model, is testing how is my jollof rice, validates the model, and then you can be sure that you have a good model. So applications of machine learning in geotechnical engineering these days, starts from the everyday tasks by increasing efficiencies or automating processes, automating some repetitive tasks, and to more core geotechnical analysis and geohazard assessment. So I gave some examples here, and I was at one of the AI machine learning sessions earlier today, and there are great applications that have been identified, and this is just going to keep growing and evolving. So the first one is analysis of big data. Now you can you have big data such as Laide point cloud data. You can do your geomorphic change detection from repeat Laide data. You can do some landslide prediction. So where is it going to occur? How much displacement am I going to get? Flood risk assessment, infrastructure monitoring, bringing in satellite data to see how things are changing, the deformation on the ground. Early warning systems also based on the models developed. So if we have such a wide variety of great applications of AI, machine learning, LLMs, why are we not embracing all these new technologies, new approaches? And another question here, are you aware that you're already using the fundamentals of AI in your day-to-day geotechnical analysis? Well, it is statistics. So some of us may recognize the plots that's shown here, plotting the volume of landslides induced by earthquakes against seismic moment of that earthquake. So they put the data together, plot it, and try to fit the best line. And just to find a relationship between the volume and the seismic moment. So again, that is what machine learning is about. It's about advanced curve fitting. All right, so what's the ideal approach? In my opinion, I think we should bring in good data. We should have human expertise, and also we should have the appropriate model for the right application. So going into the reliable data, you want high resolution data from reliable sources. You want to integrate multiple sources of data. So Laide can tell you what's happening at the surface on the bare earth, but what is going on underground. So fusing together all these different sources of data. We need the good data to be able to train the model, validate the model, and calibrate the results. Another very key part of it is the people, the people who are working on the model development. So, do you have experienced geoprofessionals that know what they are doing, that know which data matters, that know what the results should look like? Does it make sense physically? Or they know which thresholds to set for you to take action once you reach the set thresholds. Also trained machine learning experts, people that know what kind of parameters to use, that know the appropriate model for the application that it's being used for, and knows how to tune the parameters from the results they're seeing. So all these three together are quite important. More questions. So will AI replace geoprofessionals? Will AI replace other geotechnical assessment methods? Well, in my opinion, I think that just like the oven can't replace the chef, AI cannot replace the geoprofessional. Or just like the baking method cannot replace the traditional firewood method or the stovetop method, it cannot replace, AI cannot replace our empirical models or our numerical modeling. So everything needs to work together as a hybrid to complement one another. So I see AI, machine learning, as another tool in the geotechnical kitchen, so it is not a replacement. All right, final thoughts on this. So our goal at the end of the day, well, I'll start with the chef's goal, is to prepare delicious plates of jollof rice like this to the restaurant customers or the catering clients. And also, as geoprofessionals, as asset owners, operators, we want to truly build a resilient infrastructure system. So would encourage us to be open to innovative ideas, to the new technology-driven solutions, and we can truly build the resilient infrastructure systems. So with that, I'd like to thank you for your attention and enjoy the rest of the conference.